Allow me to introduce myself. My name is Adam Andresen. I'm currently a sophomore at the University of Kansas studying aerospace engineering. And today I'm going to be talking to you about extracurricular research in aerospace engineering. I'll talk about my experience. I'll talk about some other avenues other students could potentially go in. So without further ado, let's jump into it. All right, so the way that I got involved with doing research outside of my class, or doing extracurricular research, was actually through a class. So it's technically curricular because I got credit for it, but it's not something that's typically in the course for an aerospace engineering degree. So the course is AE 592, Special Projects in Aerospace Engineering for undergrad students. And this is not your typical course because it isn't simply something you sign up for. I had to reach out to a lot of different professors here on campus. I got a lot of rejection emails back from them, but fortunately, Dr. Barrett was willing to take me on, and he just had a few simple questions for me in the onboarding process. What's my transcript look like for KU? Am I okay with working with munitions and weapons technology? And that ties into some of the images I've included on this slide. The pile of Outlook icons, because it took a lot of emails to reach out to the right professors to get this opportunity. There's Dr. Barrett in the middle. And I've included the C-130 next to the Boeing 747 because, the research that you do, it's your personal choice. I personally was okay with working on munitions and weapons technology. That's kind of what Dr. Barrett specializes in. But if you're not comfortable with that, you by no means are getting forced down that road. There's plenty of different civilian and commercial options you can do research for, especially with the variety of topics that professors are researching here at KU. So moving on from that, my research can be broken down into two main parts. The first part was the collection of a historical database of all air-to-air shoot-downs from 1946 to present. And let me tell you that was a lot of different planes. One thing that I really appreciated about this project was that it deviated from other research I've had to do in other classes where typically you just go to one easy website or you go get the specific book from the library and just kind of copy the information into your report. This was much more intensive research, I'll say, because a lot of those records, they're spread out between dozens of countries across a span of more than 70 years. Most of them have to be translated into English, and then they have to be formatted into a form that the database can accept. And this database can then be used for future researchers to do analysis of like which planes typically win in which engagements and which systems are more effective against which others. So I also learned a fair bit about international conflicts as a coincidence of this bit of research, but I'm willing to accept that. I'm not a history major, but it did add some more richness and some more a greater sense of reality to the database that I was compiling. And the second part of the research that I did is a real mouthful, which I will attempt to say in one breath here. It was conducting photogrammetry analysis of supersonic hard launch munitions using Schlieren imagery and a custom MATLAB program. And because I don't have space for about 30 bullet points on this slide, I will be breaking down that statement one by one. All right, so the first part is the photogrammetry. That's simple enough. That is deriving real world information from something that's recorded secondary to an event. So if you take a picture of, say, a tower, or if you, in this instance, take Schlieren video of a bullet passing in front of a parabolic mirror, it's really hard to measure how fast that bullet is moving when it's actually moving in real time, because if I take my ruler, I can't move it along with the bullet as it's flying through the air. So I have to derive that information from video evidence. So in this instance, we can tell how large that bullet is. So I have a size reference scale, and this video also comes with a timestamp. So now I can derive things like velocity and the acceleration of the bullet. Moving on from that, supersonic, that's fairly easy. It's moving faster than the speed of sound. As you can tell, coming off the tip of the projectile, you see that cone, or I guess maybe you're seeing it like this. You see that cone that's coming off, that's the shock wave. We can measure that angle to determine the speed at which the bullet's moving. And we can also use that to check our size reference, because we can use our size reference and our timestamp to check velocity. We can use the angle to make sure they line up to make sure that everything is correct. Hard launch munition simply refers to the fact that there is no integrated propulsion in this projectile. So a missile has a rocket booster coming out one end that can be redirected mid-flight. It can accelerate variably depending on how you want to control it. That's not a hard launch munition. After this thing leaves the barrel, it's simply under the influence of drag and gravity. And another part of the research, which I won't really talk about too much in this presentation, was going through the development of different intermediate hard launch munitions as used in different airframes. So there's a lot of different varieties, and they have different applications. High explosive, fin stabilized discarding sabot, and depleted uranium rounds. I won't really talk about those too much because it's not important to the research, but I really appreciated this section of the research because it really went beyond what is offered in most of the classes here. You don't learn about the semi-hydrodynamic nature of depleted uranium rounds in intro to aerodynamics or anything like that. So moving on a little further, Schlieren imagery is how this kind of wacky black and blue and purple image was produced. In short, you have light projected out of a point. It bounces off a parabolic mirror. It passes through the light and through the shock wave that are produced by the bullet, and then it's refocused back into a camera lens. And because light moves slower through denser air and faster through less dense air, that is how we're able to see so clearly things like the shock wave and the wake artifacts behind the bullet. So this is useful just for tracking things like the wake artifacts and determining the size of the shock wave and the distance between the shock coming off the nose and the normal shock coming off the side of the bullet. And MATLAB, that was at the very end of that statement. MATLAB is the program that I use to process all of this data. It's a program you'll likely learn in your first year of classes here. Me and MATLAB have kind of a love-hate relationship. Whenever it's doing what I want it to do, I love it. Whenever it's telling me I told it to do something incorrectly, I kind of hate MATLAB and myself for telling it to try and do that. But this is also an expansion of the MATLAB course that I took, and I had to combine my knowledge with a lot of the different mathematics courses that I've taken. So this was an awesome opportunity to take all of that knowledge that I learned separately and apply it into one purpose. And if I'm not mistaken, oh no, there is one more slide. Some of my favorite things about research is that, like I mentioned, it's not following a rubric. Integrity counts in that the research that I turn in ultimately is dependent on me, and I'm the quality control for this. I'm not just following a rubric to get whatever points are available. The integrity of the information that I provide is entirely based on me, and that is a welcome relief from, I'm sure a lot of you might feel from following rubrics in other classes. This isn't simply a demonstration of a certain skill that I'm trying to learn. This is an application that is pertinent to real life. And like I mentioned several times before, this really branches beyond some of the other courses. I wouldn't have learned about all the different international conflicts if it hadn't been for the air-to-air shoot-down record that I compiled. And I definitely wouldn't have applied all those mathematical principles to a MATLAB program as early as I did if it wasn't for this research. So it's a really unique experience that I would encourage everyone to get into if you do find the opportunity.